Good morning, Calcers. So I'm making you watch this video because there were several silly mistakes done on that mini quiz the last time. Not because I want to get my YouTube views up and in hopes of being a calculus influencer. No, I can't. You guys know that. All right, so first thing, we started out with dy dx equals y over 2 radical x with an initial condition of y of 4 equals 1. All right, so first thing we do is we separate the variables. So I'm going to multiply by dx and divide by y. So I get 1 over y dy equals 1 over 2 radical x dx. All right, now at this point, we want to rewrite it so that we can take the antiderivative. This side is already pretty straightforward, so I don't need to worry about rewriting that. It's this side that I saw a bunch of silly little mistakes that went on with the rewriting of it. So I want to just kind of point that out. This is 1/2, 1 over 2. So the coefficient should be 1 over 2. All right, so 1 over 2. And then it's a square root of x in the denominator, so it's x to the negative 1/2 dx. All right, so we're not bringing that 2 up because the 2 is in the denominator. That's a coefficient. All right, 1 over y dy. All right, so now I can integrate both sides, aka find the antiderivative. So once I do that, this is going to be ln y, absolute value of y, equals, add 1 to the exponent, x to the 1/2, divide by the new exponent, 1/2 divided by 1/2 is 1, plus c. All right, so at this point, I can either choose to plug in my initial condition because I do know what ln of 1 is, so I can do it that way, or I can do it another way. So I'm going to do the 2 ways that I saw people solving it, so I'm going to show you both ways. So this way, if we plug it in right now, I could do ln of 1 equals 4 to the 1/2 plus c. So ln of 1 is 0, equals raised to the 1/2 is the square root, so the square root of 4 is 2, plus c. So we get c equals negative 2. Now if we use this method, that means I have to plug c back into this equation right here. So it would be ln absolute value of y equals x to the 1/2 minus c. Minus 2. Boop. All right, so if I use that method, then I could solve for y by taking the e of both sides. So y equals e to the x to the 1/2 minus 2. And that's it, done, boom. Okay? Or if I first solve for y, and I do ln absolute value of y equals x to the 1/2 plus c. So if I first solve for y, e both sides, so I have an e to the plus c. That is a big old c out in front. E to the x to the 1/2. Sorry, I keep whacking the thing that's holding up my camera. Equals y. All right, so now plugging in 1 equals c e to the 4 to the 1/2. So 4 to the 1/2 is the square root of 4, that's 2. So 1 equals ce squared. My dog has the hiccups in the back, if you can hear that weird noise. Just explaining that he gets allergies. So we divide by e squared to solve for c. So we get c equals 1 over e squared. So we can write it as, we would plug this c back into this one. So if we use this method, I would do y equals 1 over e squared e to the x to the 1/2. Now, these wind up being the same thing just to show you, so I could box that in and say that's my final answer. But just to do a little bit of like math behind it, algebra style. So 1 over e squared is technically e to the -2 times e to the x to the 1/2. And remember, when you have the same base, you add those exponents, so it would technically be e to the x to the 1/2 minus 2. Ba-da-bup-bup-bup. All right, so that's kind of one of the things that I saw people solving for the -2, and then they put it into this style one. So depending on which path you choose, you have to plug that C value back into the form where you plugged in your initial condition. So because I plugged in this one here, I would have to use this form. Because I plugged it in using this form, I would have to plug it back in using that form. Okay, so just wanted to clarify that a little bit better. All right, have a good one.